Okay, we've moved on to part 3 of our lesson, which is going to be over rotations. Okay, so we're going to learn about rotations about points that are not the origin. Now, before I start reading this, I just want to say, in math, a lot of times, the way that information gets presented in textbooks makes it seem very complicated when they're really just describing something that's really simple. And it's a little frustrating sometimes that like such simple ideas are written in ways that sound complicated, but to a mathematician, this stuff that we're about to go over is the shortest, most precise way to describe what we're talking about. Whereas we could make it a little clearer if we made the explanation a little longer and wordier. If we kind of described it using more words, it might be a little clearer. But the reason why these descriptions can tend to get kind of confusing is because they just tell you just enough information to understand the point. So if you don't follow everything that is told, then you're not going to understand the overall concept because they've basically given you just the bare bones information that will describe what they're talking about. Okay, so let's go through that description. So a rotation about a fixed point P through an angle of A is a function that maps point M to point M prime such that point P does not move. The measure of angle MP prime is A, and the magnitude of MP is the same as the magnitude of M prime P. Okay, so the first one, point P does not move. They're saying when we rotate around some point, that point does not move. So if I use my pencil real quick, if I said my point P is going to be the tip of the pencil and the point that I'm moving is going to be the eraser, well, it should rotate around the tip and the tip should not move. Okay, so point P that I'm rotating around does not move. The measure of angle MPM prime is angle A. That's just the definition of what we said. We're rotating it through an angle of A. So we're rotating it through this whole angle. Okay. And the magnitudes are the same. So the length of these dotted lines are the same. Now, when we use the word map is a word in math that means to kind of move from one place to another. Now, that could be a physical movement on a graph, or it could be a more kind of vague concept of movement, kind of like if you had the equation y equals x plus 3, you're taking your x values, you're adding 3 to get your y value. So that's a sort of mapping. The mapping from x to y is by adding 3. Okay, it just kind of means a change in math, a movement. There's kind of different ways that you can describe what mapping means. In this example here, though, mapping does mean to move. It means to move from one location to another. So the function that maps point M to point M prime is our rotation. When we say function is something with an input and an output. So our input is this, our output is M prime, okay, and our rotation is the function that gets us from one to the other. Okay. When a point is rotated 90, 180, or 270 degrees counterclockwise about the origin, you can use the following rules to determine the coordinates of an image. A rotation of 360 degrees will map an image onto the pre-image. Okay, so if you go 360 degrees around the center, you end up where you started. Now, these rules that I'm about to say only apply to rotating about the origin. Okay, there's adjustments that we can make to it if we're not doing the origin, but these only apply to the origin. There are ways that we can figure out general rotations about any point, but we're going to start kind of simple and talk about just kind of take a little piece at a time. So a 90-degree rotation moves you from xy to negative yx. Okay, so that part looks a little confusing. So let's just give it some example numbers. So if this was 3, 1, if we were at the point x is 3, y is 1, our new point when we rotate 90 degrees is going to be 3, 1, is going to be negative 1, our y value was 1, negative 1, comma 3. Okay, on a 180-degree rotation, we're just going to end up with the negative values or our true coordinates, and a 270 degree, a 3/4 turn, is going to take our x and y coordinates, they're going to flip them, and the second one will become negative. Okay, so let's just look at that with a full example where it's a little easier to follow than that just general description. Okay, so try to get this so we can see it all. Okay, there we go. So on here we've got hopefully you guys can see that the right way. If not, maybe that flip helped. Okay, so our original point xy, which is over here, 3, 1, is going to become negative y comma x. So our y value is 1, so negative y would be negative 1 and 3. Okay, negative 1 and 3. For a 180-degree rotation, we do 2 quarters halfway around the center. So we rotate it once, twice, and we're at negative 3, negative 1. So we just change these numbers. They become negatives. Okay. For a 270-degree rotation, so 90, 180, 270 degrees, these two numbers change place, and the second one becomes negative. So instead of 3, 1, we get 1, negative 3. Okay. That's just, if you kind of notice, it's actually just this one if you flip the signs. So the negative 1 becomes positive 1, the positive 3 becomes negative 3. Okay, just like these two switch signs. So 180-degree rotations just switch the signs. 90-degree rotations switch the x and y with each other. So rather than 3, 1, we have negative 1, 3. Okay, and there's a negative sign that gets introduced as well. So those are kind of characteristic movements. We like to initially learn about 90 degrees, 180, 270, 360. We learn about those like quarter turns. And then once we feel confident about those, we can move into any little bit in between there. But it's good to get started with something kind of fairly simple. Okay, so we'll move on to example 1.